Hey, we have here today an interesting integral from the UNSW Integration Bee. This was 2022, knockout round 2, problem 3. We have the integral from minus pi over 2 to pi over 2, cosine x, 1 plus arctan x over 2 minus cosine squared x dx. Okay, at first I didn't really know where to start with this. I was kind of stuck for a moment, not really finding a good way. But the thing that occurred to me is because we have these bounds that are symmetric, I might be able to do a very simple substitution that's going to help us out. And what I came to was, if I just substitute u equal to minus x, that's going to flip these bounds around. So doing this, of course, x is going to be just minus u, and then dx is going to be minus du. And we'll make this substitution, so that's going to change pi over 2 to a minus pi over 2, and it's going to change this lower one to pi over 2. And then we can just plug a minus u into here wherever I see an x. But now we have this minus sign on the du, and what I'm going to do is take this out front of the integral and just use it to swap my bounds around, so I can put this back to a positive pi over 2, and this will be a minus. Now we're back to what we were originally. And now cosine is an even function, so these minuses are just going to go away. I can change these into pluses. And then arctan is actually an odd function, so what I can do is take this minus sign out here, and we'll put this minus sign right here. And then next what I want to do is a variable change. We'll just get it back to x, because what I'm trying to do is I'm trying to line it up where I can add it back to the original integral. So we need everything in x, so let me just change that right now. Okay, and at this point, now that we have the same variable, we're all in x, we have the same denominator here, and we have the same bounds. What I'm going to do is, let's call the original integral just I, and then we'll call this integral I. And then we're just going to add these two together. Okay, so we're going to have our same bounds that we have here. And like I said, we have the same denominator on these, so we'll just keep that 2 minus cosine squared x. But now when we add the numerators, we're going to distribute in the cosine here and here. So we're going to have just a cosine x plus a cosine x. We're going to have a 2 cosine x here. But then for the arctans, we're going to have a positive cosine times arctan and a negative cosine times arctan. So those terms are going to cancel and be 0. So we're just going to leave that off, and we'll put our dx there. But that cancellation really helps us out, because now we have a simpler integral here that I think we can do. Just notice here that cosine is an even function. So actually this whole thing is going to be an even function. And because we have symmetric bounds here, it's going to let me use that property where I can change the lower bound to 0 and bring a 2 out front. But now I can divide off a 2 on both sides, just so that we're getting back to just finding our I, our integral value that we're looking for here. But actually, I kind of wish I canceled this 2, because I actually want to bring that out front, and I already had it there. So let me just bring this 2 out front of the integral. Then from here, what I want to do, I want to use the identity that 1 minus cosine squared is sine squared. The only problem is we have a 2 right here. Well, what I can do, that's easy to fix. We'll just write our 2 as 1 plus 1 here. So then this 1 minus cosine squared, this piece is actually going to be sine squared of x. But then at this point here, I think we're in really good shape for a u substitution. But I guess because we used a u earlier, I'll just use a different variable. So let's do a v substitution. Even though we could reuse it, let's just be polite and use a v substitution. So I'm going to call my v for this integral here, we'll call v equal to sine x. Then our dv is going to be cosine x. And so I'll just try to squeeze in this v substitution here, like really small. Okay, just kidding. I don't think you can see that. So let me clean up the board. Okay, so now I'm ready to do this substitution with my v and dv over here. So we'll bring our 2 out front. We'll plug pi over 2 in for x here, and so our upper bound is going to be 1. We'll plug a 0 in. Sine of 0 is just 0. And then our numerator is going to be just this dv value, but of course I forgot my dx. Sorry about that. So we'll have our dv here. And for our denominator, we'll have 1 plus v squared. But when we integrate this, this is actually just going to be arctan. So we're going to end up with arctan of v, just evaluated from 0 to 1. So evaluating this, we're going to have 2 arctan of 1. Well, arctan of 1 is just, happens at pi over 4. And then we need the arctan of 0, but that's just 0. So we just need to distribute this in, and we're going to have our final solution of pi over 2. So that's it. Really like that one. So we'll stop it there. Thanks everyone for watching. Please like and subscribe. Have a great day.